In this video, we will talk about what probability is. So we'll try to give a definition for it and then do an easy example where we evaluate the probability of something occurring. So the scenario I want to begin with is, suppose that we have a fair coin. What is the probability that when we flip it, that it lands on heads? So when the question is asking for this word probability, this is a measure of how likely this event, flipping heads, is. So we'll talk about two approaches to computing probabilities. So the first approach one, I'm going to call relative frequency. So relative frequency. And in relative frequency, the idea is that we can flip the coin many times and compute the following. We can compute the number of heads that we get and divide it by the total number of flips. So for example, I'm going to put this in parentheses and write e.g. for example. Suppose that we flip 100 times and we get, in those 100 flips, maybe we get 48 heads. So maybe it lands on heads 48 times and tails 52 times. Well, in that case, the probability, it turns out this is an estimate of the probability, so I'm going to write an approximate equal sign, is 48 over 100. Or as a decimal, this is 0.48. Okay, so the more times we flip the coin, the better of an estimate that we get. So when we compute a probability in this way, I want to talk about the advantages as well as some of the drawbacks to doing it like this. So the main advantage is that this is helpful when we have no simpler way of computing the probability. So often this is helpful where our experiment is such that we really don't have an idea of what the probability is going to be, or if there's just no simpler way of computing that probability. Okay, so what are some of the drawbacks to doing it like this? So this is sometimes hard to do. Sometimes it's hard to do an experiment many times, especially if we have to do it manually and ourselves. It takes a lot of time to do an experiment, enough times to get an estimate for what the probability might be. Another drawback is that this only gives us an estimate of the probability. We don't know the true probability by doing it like this. Okay, so in our class, we're mostly going to be focusing on a second approach for computing the probability. And the second approach involves using some type of deductive method. So some sort of deductive way to reason out what that probability is. So the one that we're going to be looking at most is what's called equally likely outcomes. Okay, so in this example, intuitively, there are two equally likely outcomes from flipping a coin. Either it lands on heads, which I'll call H, or it lands on tails, which I'll call T. So I'm not going to consider the possibility that the coin lands on its side. So I'm going to say the only options are heads or tails. So I'm going to introduce some notation. I'm going to write P parentheses H, which out loud in words I say P of H. But this notation is going to refer to the probability, so the P stands for probability, of, and inside the parentheses I'm writing the outcome. So this is the probability of flipping heads. So intuitively, this probability is 1/2, because landing on heads and landing on tails, they're equally likely. So it should land on heads 1/2 of the time, and that's why I'm saying the probability is 1/2. So we can give a more general definition of probability when we have equally likely outcomes, and that's what I want to do next. So suppose the sample space S of our experiment, and remember, sample space is just the set of all possible outcomes of the experiment. So suppose that sample space has equally likely outcomes, and E is an event in S. So in the example we're looking at above, our event was flipping a head. Okay, so then the probability of that event E occurring, so using my notation for this, we'll denote this as P of E, is going to be the number of elements in E divided by the number of elements in S, or the total number of outcomes. So often I will write this in more informal language. So the number of elements in E, I'm going to call the number of successful outcomes. So counting how many outcomes I care about. And then on the bottom, I'm going to divide by the number of total outcomes. That's what the number of elements in S, my sample space, refers to. Okay, so using this framework, we can write down the probability of flipping heads in our simple example that we had set up initially. So in this case, flipping heads, this is my event that I care about. I'm going to call this E. So using this formula, I'm going to set up a fraction, and on the top I need the number of successful outcomes. Well, in this case, I have a successful outcome if I flip heads. So this is the number of ways to flip heads. So I'll just write H for heads. And on the bottom, I divide by the total number of outcomes, which in this case refers to the total number of flips. So how many ways are there to flip heads when I flip a coin? Well, one way, because I flip a head. And then for the total number of flips, there's 2, because I could either flip a head or I could flip a tail. And that gives me 1/2. So this was a simple example to explain how this formula for probability works. But over the course of the next few videos, we will gradually do more examples and increase the complexity. So in terms of our goals for this section, we have finished our second goal, which is to define the probability of an event occurring. In the next video, we'll look at some properties of probabilities.